Okay, thank you so much for having me. These are some slides I've put together. Hopefully they make some sense about what physicists have to offer startups. And I think that that's a lot, and it's one of the reasons why I made the move, because not only did I have a lot to offer, I also found the problems really interesting. So without further ado, let me describe what I'll be talking about today. So first I'll be describing sort of physicists and technology, just like what the overlap between physics and what's going on in the world and sort of what we have to offer. Second, I'm going to give sort of a startups 101 background, because I think there's a lot of misconceptions about what startups are. And I think it's sort of interesting. And if you're ever thinking about starting a startup or what makes a startup successful, why startups make certain decisions, I put together just a little brief tutorial on sort of like what the underlying business model is of what a startup of startups. Then I'm going to describe Quora and what I do at Quora and some of the and just one of the things that I can speak about on which I think demonstrates some of the tools that physicists bring to the startup world. And then I have a sort of FAQ section on startup life about questions that I've been asked repeatedly. Yeah, so I'll move on from there. So the past 20 years have been really amazing in terms of like where we've gone with technology. Basically, we're in the middle of having the world digitized, going from sort of an analog world, but to a world where computers are at the core of everything that we do. This has been because of the growth of processing speed, the ability to store large amounts of data, and then the increase in network bandwidth so that we're able to send this information around very quickly. But I really, while this has been really amazing, the biggest question for me when sort of thinking about, maybe you might call it a midlife crisis, what's the most important thing I can do with the rest of my working lifetime? And you know, things that actually use my 20 years of experience in physics. So what's the best thing I can do as a physicist to make an impact upon the world? And we know that we've seen a huge impact in technology upon everything that we do. So first, you just look around at physicists in Silicon Valley. There's a lot of things happening, Google, Facebook, lots of other major companies that you know. And it seems like the things that are happening in industry are relatively easy technically in comparison to sort of the problems that we're trying to solve in physics. I mean, think about like what the LHC does. I mean, that's really hard. Whereas figuring out how to make Facebook more engaging, that seems relatively interesting. Figuring out search, I mean, that's a hard problem, but compared to understanding the laws of nature, that seems relatively, more straightforward and tractable. So it feels like these are things that physicists can make an impact in because we're very general thinkers. And just to give some examples, I'm just a little outdated, but there's Jonathan Su, who was the first head of data at Facebook. Now he runs data science at a venture capital fund. He was a graduate student at Stanford while I was a postdoc there. He very talented and did very well. Michael Salem is now a manager of data scientists at Facebook. Kevin Weil was actually the senior vice president of product at Twitter, and now is actually running product at Instagram. He was actually a master's student of mine. And then Jonathan Zunger was a student at Stanford while I was a graduate student at Berkeley. He ran Google Plus. So these are all like physicists, just a small sample of them, that have done like pretty cool and amazing things just in the very recent past. And so, these people seem to have made an impact doing various different things. I mean, Kevin, with his work at Instagram, has basically destroyed Snapchat. So that was his vision to bring Instagram stories. That's kind of cool. So what do physicists bring to the table as sort of scientists? What sort of general skills do each one of us have by just the training that we get in both the classroom and in the research laboratory? So the first one is thinking in terms of space and time in many different contexts. So whether it's the CMB, thinking in terms of spherical harmonics and sort of abstract spaces, thinking about time series, thinking about networks. I mean, we can think about space and time in very creative ways. Acceleration, motion, velocities. These are all things that we take for granted because they're just so obvious to us because we've been inoculated with them since we were teenagers. And so they're just second nature to us. But you go around to other scientists at in various disciplines, and these are not natural things to be thinking about in the way that we think about them. Notably, like economics. They don't think about space in the same way that we do, right? So we have a lot of unique perspectives. Second is that we naturally think probabilistically with our training in quantum mechanics. The world isn't deterministic. There's a lot of uncertainty. We can just handle it very naturally in terms of just like thinking in terms of like how things can interact with each other in non-classical ways, in ways that you may not be able to simply understand. And so this training in terms of quantum mechanics and interference and statistical reasoning is very powerful, and sort of at the heart of a lot of the machine learning that we have today is probabilistic models. We're very good with abstract spaces, thinking about tensor spaces. One of the big achievements recently is something called TensorFlow from Google. It uses multilinear algebra, which they call tensors. They find it very difficult mathematically to think about these different objects. Every one of us who takes a general relativity can think about a 4-index thing in a pretty straightforward manner. We can think about, if we deal with quantum mechanics, taking tensor products of states, so we can think about how to combine and make bigger spaces. These are just things that we can do just by a lot of our training. And so by being comfortable with sort of abstract spaces, we can take advantage of a lot of the most advanced techniques coming out of the research labs, and just both be able to understand them and then also be able to understand how they generalize and be able to apply to new specific problems. And do this better than computer scientists can, in my opinion. Then we have just the applied statistics that we have, which is used all the time now in startups, p-values and thinking about the look elsewhere effect. So being able to do careful statistical reasoning, we're very good at that. Perhaps not as good as statisticians, but we know this really well. And so these are like really important skills, so that when you're analyzing, like, oh, I made this change to the website, or made the change to the algorithm, is this statistically significant? We can understand this very quickly. We can do back of the envelope calculations to understand whether a analysis could be statistically significant or not. So these are just stuff that we know. And then we also work with big data. The LHC records on its chips a 10 megabyte event every 40 megahertz, right? 40 million times a second. That's a huge amount of data, and we know how to deal with it, and we know how to process it and slice it down and deal with all of the individual, like turning that data into information. So these are just tools that we have available. And these are all transferable skills that we develop as researchers in physics. So that's a lot that we bring to the table, in my opinion. So then the question is well, what problems are actually being addressed right now in Silicon Valley and startups in the tech world in general? How impactful are these things? And what are they? To know like where our particular skills can be applied. So one of them generally falls under reputation and recommendation systems. So being able to know which restaurant at Yelp is appropriate for you, being able to give you good recommendations on Netflix, Amazon. These are all ranking systems, being able to figure out which one is best for a given individual. So the personalization. So we're going to a world where we expect companies to know exactly what we want. That if you just have some random suggestions there, you aren't going to have the patience for it. We don't expect to scroll through a big, long catalog line by line. We want to be able to have that serendipitous moment of saying, oh, this is the perfect restaurant I would have never gone to, but because so many other people like me had liked similar restaurants, had also liked this restaurant, we can go to it. Similarly with Netflix. This is becoming sort of just commoditized technology, but it's really important. And we're taking this into new regimes, into even more challenging regimes. So like Netflix, it's not really that hard. There are how many movies in the world? Maybe like 5,000 that you might be interested in. So that's not that hard to surface. But at Quora, I'll describe how we need to identify which question out of millions you need to might be relevant for you to answer. And so that's a much harder problem. And so this is just generally an area of growth where we're getting better and better at. And there's a lot of machine learning in that. Second thing is understanding language. We can kind of do a little bit of this now. This is called natural language processing. And basically, what we're trying to do is take text, which is a very processable form of data, and sort of understand what it means. Like understand the intent behind it, what statements it's making, like in terms of first order logic. So this is actually TensorFlow here. You see some multi-index objects. And so Google is building a knowledge-based trust system based upon taking natural language statements and then transforming them into these first order logic statements, and then trying to combine them across the web to get trying to understand what is true and what isn't true, to understand which websites are fake and which websites are real. That sounds like a really hard problem, and we aren't very good at it. Autonomous systems. I think we all know that self-driving cars are coming pretty fast. Whether it's next year or 5 years, they're coming very quickly, and they're going to take all different forms of motion. So they'll be able to move on their own. They'll need to be able to, they spatially reason. They need to be able to communicate with other cars, and they need to communicate with humans on the street and bicyclists. And so this is a really hard problem that we're addressing right now. And I think we all sort of get the feeling like we're getting close to being able to crack this. And so this will be like transformative to society because our entire cities are built around cars. And if we change how cars behave, we change our entire city structure. Finally, Internet of Things. Everything has a chip in it now. These things are really terrible. And I think we all expect that they could do better. And that we will have something better 20 years from now. I think most people would admit. And it's probably not the old conventional refrigerator or thermostat, but something a lot smarter. And somehow we have to get from where we're at today to where we're going. And right now it's just a world of very bad products. Also, medicine and genomics. I mean, this is still how a lot of our medical records are stored. And we've digitized some of them, but actually turning all this data, which is now in plain text, into actual information, mining that information, and being able to figure out how to save people's lives, figure out like new treatments, or figure out which old treatments aren't effective. This is all just data sitting there that technology is hoping to address in the next few years. So while it seems like we've come a long ways, we really haven't. We've digitized documents. We've sort of automated information retrieval. We've digitized communication. We've connected society. These are all big changes. But I really think that the most impactful changes are still coming. So understanding information and intent. So being able to actually know what that statement means. Like I want to, we see this a little bit with Siri being able to like say I want to schedule an event. I want to make a reservation at a movie. I want to send money to my parents. These are all like very basic things, and we're only just barely able to do this now. And if you think about being able to take this to the next step, that's going to be really transformative in terms of how we interact with computers. With the autonomous vehicles, we're going to be automating transportation and the whole supply chain of how we get products from A to B, how we assemble them. This is going to be really amazing at changing the entire notion of how we build things. We need to finish digitizing the world with the buildings and appliances, and finally bringing medicine out into the 21st century, some of which still sitting in the 19th century. Okay, so that's I think just a survey of like where we're at, where we're going. I think these are cool problems, and I think that our skills as physicists give us a chance of making like unique impacts upon each one of these problems. So let me describe startups by first defining what they are. Most people, I think it's really hard to get a clean definition of what a startup is. And Steve Blank, who has spent a lot of time thinking about startups, came up with a definition that most people use. And it's really loaded, so I want to deconstruct it. So a startup is a temporary organization used to search for a repeatable and scalable business model. And this is like, seems like businessese, right? Like who knows what the heck any of these words mean. So I want to start with that last one, scalable. This is really one of the most important things when you think about like making a successful startup. What scalable means is that it can actually experience exponential growth. That's the real essence of it. And what experiences exponential growth? Well, it's when your growth rate is proportional to yourself, proportional to the value itself. And so if you ever look at a startup business model, which you probably haven't, but they often look like this. You see loops in there. And the reason why they have loops in there, because those loops are how they close back and get the growth to be proportional to that value itself, like to how big you are. And so that means that as you get bigger, you grow faster and faster and faster, and you become more and more dominant. And so that's the goal of a startup, is to come up with a scalable model for how you create something. And I'll describe Quora's scalability in just a few minutes.
So if it's not exponential, does it fail?
Very often, because you're starting off as very small, and the best way to grow something, growing linearly is not good enough. Linear growth isn't good enough. No, I mean, if you're starting off slow, I mean, you have to be increasing your growth rate. If you want something that's going to have 1,000 people that use your product, linear is great, but you need to go from 1,000 to 2,000, then 2,000 to 5,000, then 5,000 to 10,000. How are you going to get to 100,000 people or 1 million people? That can make a small business, but that won't make a startup. So startup, not all businesses are startups. You don't have to be a startup to be a successful business. In fact, startups frequently fail, but this is what they're trying to do. They're trying to become dominant.
So there's a distinction between just starting a business and a startup.
Exactly.
And that distinction is
this entire definition. Yep. And so one of the core aspects is the exponential growth, because you want to become the dominant force. You don't want to be one of many small players, because if anyone else comes along that has this, they will destroy you. And your nice small business will be gone. And that's what's happened repeatedly. So that's why this is why you're searching for this type of model, to be defensible. Repeatable. You don't want to burn out your population. So if you're familiar with the SIR model of epidemiology, you have your susceptible population here, the people who are healthy but can get sick. You have your people who are infected. And then you have the people who are recovered and who are no longer infectable. I'm sure we all recognize a lot of startups that had this problem. Zynga and their little games. You had a lot of people who were potentially interested in playing games. They grew really fast, but then there was a strong attrition rate. And what happened is that people got tired, got burnt out, stopped using the product. And so it isn't really a repeatable model. You got this one-time burst of money activity, but it doesn't keep on going on forever. And so you end up with a burnt-out model, and yeah, that's not good. So you want to really monitor your attrition rate. You want to make sure that you don't have what's known as a ring of fire, where your old users just evaporate away. Temporary. That's failure is an option. And what you want to do is you want to fail fast or succeed. And this means that you want to focus really on your asymptotic behavior in terms of how much money you're spending. You're not immediately trying to create a self-sustaining business. And that gives you the ability to ignore immediate negative costs. So, for instance, if you're talking about like your burn rate of money, you have like some initial cost that you have to run your servers, pay your employees, and you may not be making any money at all. In fact, you may choose not to try to make any money at all, because your growth rate may have a bigger power but a smaller coefficient at the beginning, and only becomes dominant much later on. And so you are in the startup phase when you're in this temporary phase that obviously cannot go on forever. Once you get out here and can go on forever, you're no longer a startup, you're a business. So Facebook is not a startup, it's a business. Google is not a startup, it's a former startup. And so this is the startup phase. In particular, this early phase right here is where you're starting to lose more and more money the more that you succeed, which seems really counterintuitive, but this is actually the model of how things work. And there's actually a strategy behind it, which is that monetizing then growing is not the same as growing and monetizing. And the reason is that you're diverting resources to building out the monetization platform when you could be putting resources into growing. And if you slow down your growth, you're actually going to, you may actually slow the time to when you become profitable. So getting big is the most important thing in startups. Yep.
So if the startup fails, what happens to the employees?
Well, the employees hopefully got paid, but your stock options will not be worth anything. I mean, hopefully, frequently you get acquired and you get something out of it because you've created intellectual property. But yes, I mean, you don't want to be part of a failing company. So yes, so if you think a company has no chance of succeeding, I wouldn't work at it. But yeah, I mean, it's for the employees of companies that end up failing, it's not good. I mean, you get your salary like anyone else, and so that's good, but the upside isn't there. Okay. So just to summarize, so technology startups want to transform the world via technology, and you don't want to do this with like having only 10 people that are doing something. You want to have 100 million people, 1 billion people. You want to be big. You want to be a dominant market force. You want to transform a major area of the world. You want to get better the bigger you get. So if you're thinking about like your business and your core product actually, if it's intrinsically going to get worse the bigger you get, you're going to have real problems, right? If the more people that use it, the worse the experience gets. So if it requires like everyone to know each other for this product to work, that's going to break down as you grow bigger. So you need to make sure that whatever you're building is going to get better as you get bigger. You need to go from nothing, because you're starting a brand new company, to something, and you want to get, and then go from something to become everything. You want to be the one place that serves what you do. Otherwise, someone else will try to go from something to everything and take you over. And so this really requires exponential growth. That's the easiest way to get there. That's the easiest way to prevent yourself from being blocked. And then you're going to start off losing money, and you don't want to start off bootstrapping, because growing and monetizing do not commute with each other. And then finally, there's an old adage when you're thinking about what your product is. You want to solve some people's real problems in the world, and so there's an old analogy. Do you want to be a painkiller, or do you want to be vitamins? Vitamins are things where you take them, and over time you'll do something good for you, but you don't feel any immediate benefit to your life. Vicodin, you're going to feel real good real fast. And one of them is more likely to succeed than the other. I'll let you figure out which one. I'm not endorsing drug use. Okay, so let me describe Quora. Our mission is to share and grow the world's knowledge. And what we're organized as is a question and answer knowledge base, so hence a lot of the Q and the A's in the name. What that means is that we organize all the information that we get into a long-term repository of information where it's essentially organized by the question. And the reason why we want the question is because that's something that really indicates someone's intent, like what someone's really looking for. And we think this is actually a great platform for writing. Now, why does this? Why is this valuable? Well, a lot of people have tons of information locked away in their head. In fact, most information in the world is in people's heads and not anywhere else in the world. It's not written down in academic papers. It's not hidden away. It's just in people's knowledge about the world. And it's not accessible to anyone else except via one-off conversations. And so there's really no way of distributing all that information. Often, the people who have this knowledge don't even know that it's valuable or potentially interesting for other people. Additionally, everyone knows about a lot of different things. So I know about physics, photography. I did a lot of graduate student advising while at Stanford and SLAC. I live in Silicon Valley. I've transitioned from academia into the private sector. I also like to cook. I know quite a bit about that. And then you might think, well, isn't there this thing called Wikipedia? And the thing is, most information that people know is not factual. Most of my knowledge about physics does not belong on Wikipedia. It's not encyclopedic. It is a point of view, a way of addressing a problem, a way of thinking about a problem. It's not just strictly right or wrong. Like, you could ask 5 different particle astrophysicists about what they think about WIMPs. And they will give you 5 different answers that may fundamentally disagree with each other. And these 5 different viewpoints are valuable. And trying to combine them together into one coherent statement, you'll lose a lot of the nuance and subtlety about that. And so Wikipedia is not meant to be a first primary source, whereas Quora is meant to be a primary source. People's expertise and background and experience matter a lot. So how does it work? So a person comes to Quora and they have a question, and they write that question. Then we identify the subject of the question, which is not a totally trivial task. From those subjects, we know which people have written about it and have expertise in these subjects. And then we distribute these questions to people who, to these experts who can write answers. From those answers, we can give it back to the person who originally asked the question, but there are oftentimes lots more people who are interested in that question than the person who originally asked it. And then finally, some of these readers come back and want to become people with the questions and ask again. And so you create this cycle of building more and more. The more people that use, the more people who have questions, more people who write answers, the more people who come in to read the content on Quora, and it gets bigger, it grows exponentially. So that's the growth loop at Quora. So what does this look like? This is what a typical question page looks like. You have the question text here. You have some topics up at the top, which are the subjects of the question. I just noticed that one is probably not the one I would put there. And then you have the answers ranked order by what we think the best ordering is. So this is Ina Vishik. She's an assistant professor up at UC Davis. And she wrote a actually very inspiring answer to this question. And 60 people have given it upvotes, and I think I cut off how many people have read it, but a few thousand people have read this question, the answer to this question. So why would anyone do this? Well, I can speak for myself. So I was initially a user of Quora for a long time, and I like to share what I know. I find it fun to write and help people, write what I know and help people. However, answering a single person's question isn't particularly scalable. It isn't very useful to answer what is dark matter to a person from a high school student in email, because there are just so many more people who have that question, and you'd be answering questions all day if you did that, and the same ones again and again and again. So by writing on Quora, you can write a single, what your point of view is once, and put it up there, and many people can access it, more than just a single person who asked it. And then the other thing is that other people may not even know that they have that question, or may not even suspect they might even like to read the answer to that question, but actually do. There are a lot of people out there who really are interested in physics and hearing about experts' points of view on real problems in physics, and it's surprising. So for me, it gave me an audience. So this is the number of views my answers have gotten over time. So that back in 2013, we don't have data before then. And over the past 5 years, I've generated 14 million people have read my answers over that time. And you may think, oh, well, maybe that's just because you're writing a lot. I do write a fair amount because I enjoy it, but for this question right here about the Interstellar movie back in 2014, essentially about gravitational time dilation. It's an interesting question. People want to know. People were interested in this question. And you might think, oh, people might read it right when the movie comes out, and maybe when it's released on DVD. And you see that right here and right there. But what you see is that over time it continues to get people reading the answer, like years later. So now this is 3.5 years after I wrote this, and people are still reading it. 100 people a day are still reading it. That's a lot of impact, and it's different than a lot of other sites because the content is evergreen. It doesn't go away. We don't consider this irrelevant because it's 3.5 years old. And so it's a permanent repository, and I can continue to have impact even if I don't do anything on a given day. And lots of other people have found this. So Elizabeth Simmons, who's now a vice chancellor at UC San Diego, has been actively using Quora for several years now, 5.7 million views on all her answers, and lots of people who follow her. Adriana Hugai runs a genetics lab at NYU, so she's a professor at NYU, and has 30 million answer views. Thomas Corman wrote a famous book. He's a distinguished professor at Dartmouth on computer science, and people just loved his writing. David Joyce is a math professor at Clark University, and he loves writing about mathematics, and 208,000 people have read his answers in the past month. That's a lot of people, a lot more than what you get from a blog post, and that's every month. So why does it work? So having a question is a great writing prompt because it scopes your writing. You have a question, you know what it takes to answer it. You know what your answer is to this question pretty quickly. It isn't trying to come up with like a blog post is a nightmare. I don't know if anyone's tried writing a blog, but it's like it just sprawls out, and before you know it, you have like 12 pages of text that no one will ever read. You're talking about Goodell when you started off describing you're getting groceries in the morning, and so scoping this is really important for the writer. But then there's also this implicit contract with the reader because it lets the reader know what they're going to get at the end of the writing. So not only does it set up how much writing you expect to be able to do, it also tells the reader what they're going to get out at the end of the day. So it's a well-titled thing, well-titled article, and so they know that it's about this. I'm going to get an answer about this and learn hopefully about that question. And so this is a great way of writing, and it's why the reading and writing works on the platform. So the big challenge of Quora. A person comes in, where does optics fit into an undergraduate physics curriculum? Who do we show this question to? This is a monster ranking problem because we need to figure out who, for each person that comes to Quora and has the desire to write an answer, we have to figure out which small set of questions can we show them out of the millions of questions that we have. That's a really challenging problem. And that's ultimately a lot of our strategic advantage is that we can do this. We can show people interesting questions that will get them to write answers in a quick, low-cost way, low-cost to the writer way. So how do we do this? We identify the subjects of the questions, which we call topics, and then these topics let us aggregate expertise and interest in these different areas. So we obviously have science, but we also have physics, and physics is a really well-followed topic with nearly 5 million people who have expressed real interest in reading it. And there are like 200,000 questions, nearly 300,000 questions in the subject. In particle physics, that's relatively niche in comparison to physics, there are 400,000 people who are interested in it and 20-some thousand questions. Down to the Higgs boson, 65,000 people have said, I'm actually directly interested in this subject matter. So people have interest down to really small, really fine level detail. And because there are so many questions and there are so many answers, the expertise that we've identified around each question is, around each subject is very fine-grained. So this is my role at Quora, is the topic system, how we actually organize all the information, what topics should exist, what information we keep on them. And this is spanning all of human knowledge because any type of question is valid on Quora. So you can ask about dating and relationships, you can ask about theoretical physics, you can ask about politics. It's all okay. And we know that expertise goes down to much finer detail than just big, broad topics. So physics is not sufficient. Particle physics may not be sufficient either, even neutrinos. And possibly, if you're asking about detailed questions about neutrino masses, I know something about that. Neutrino oscillations, I'm kind of out of date on. The solar neutrino problem, I kind of remember the whole story around that. But that just demonstrates at my level of expertise, I know not about all these aspects, even though I'm nominally an expert in the subject, and other people will have complementary knowledge. And so we want to be able to route that information to to people who have expertise in each one of these areas. And so this is all falls under the ontology, which is basically what things should exist, how do we name them, what is the type system for topics, what properties of topics should exist, what is their interrelationship between topics, so knowing that physics and particle physics are related to each other, how is Albert Einstein related to physics, all these things are go under the topic ontology. And there are lots of cool things you can do with the system and as a way to leverage it to understand what's going on and to be able to improve the overall Quora ecosystem. So, for instance, determining which questions should be only shown to people in certain places. So if you get something about the GATE exam, I wouldn't have known what this was. This is a big exam in India that's really important to know, but we can actually just know this because all the past questions have been answered by people from India, or a large fraction of them. And so we can actually localize the questions, not having to know a priori that this is an Indian exam, but just based upon past usage. So developing a system to do that. And generally just taking the question text, 10 words or so, 15 words, and then identifying which small set of the million or so topics that we have belongs on this question is what's called extreme classification. And it's a really challenging, cutting-edge problem that we're working on at Quora. Facebook, Google, and a handful of other places are also really working on it. And it's really critical to our success. So just briefly, I want to describe one of the early things I did at Quora, which we called trending topics. Basically, if there's a change in the usage of topics over time, we want to be able to identify it. It might be something interesting that's happening. Maybe we want to show these topics to people regardless of whether they've expressed interest in the topic or not. So how do we do this? So you can think about there's a set of actions coming in. Maybe that's answers that have come in, questions, views on answers. And these are essentially little delta functions that are happening at a given time ti. So you have this time series of views. We aggregate these events into an exponential moving average, which has a time parameter, t0. So maybe that's a day. And so if you think about it, before the event happened, it's 0. After the event happens, it starts going down exponentially with time with maybe a day decay constant. Okay, so this lets us just combine this into something that's nice and analytic. Now, what tells us a lot of information is actually taking the difference between a short-term and long-term moving average. And if you've done trading, you know that the difference between a long-term moving average and a short-term moving average tells you about trends in stocks. And so that's what we do to identify, early on it's trending hot, and then it averages off. And this negative over here is really important because if you're getting repeated events, that negative averages out if you just have a constant rate of events so that you're getting 0. Okay, so we need to normalize this because big topics the more content that you have, the more likely you are to get to have big fluctuations. So we all know how to compute the variance with an expectation value. So you can take an expectation value, maybe averaged over a long period of time, maybe 6 months, so that you know like how big the typical fluctuations in this difference of exponential moving averages are. And then you can normalize your signal to that variation, including some offset for 0, and maybe look for 5 sigma deviations. And then you can turn that into a score that goes between -1 and 1 by just using a simple function that asymptotes to 1 when it becomes very large. And so this is what we used initially to validate. This is from 2014, so there was a war going on in Crimea, and it was trending really hot back in March, and then people kind of lost interest in it. And then right here, there was a plane that got shot down, unfortunately, and caused it to reemerge. You have the World Cup going on. You have, I think, the group play right here, going into it, and then you have, wow, everyone cares about the World Cup a lot. The initial group stage ends, and then it goes into the knockout round, and you see, woo, and then disappears, so on and so forth. You see a stupid little app here, doesn't actually trend very much, the Yo app. Anyways, so this was just something really fun that we could do, and you can just see that these trends just exist, and just from very basic, like this was less than a week of playing around to get this to work, and now it just runs in the background. And it's just fun to watch what happens. Okay, so with the last few minutes, I have a couple FAQ questions. I'm not going to write down the answers to them. So coming from physics, what topics do I need to focus on when getting a position in data science, which is the most common position that people take when joining a startup coming from physics. And from this, I'd say that we have amazing technical skills. What we don't do a great job at is demonstrating this to the people interviewing us. Really focusing on interviewing skills is the most important thing. Having some functionality like Python and SQL or some of these things is good to bone up on, but really being able to demonstrate your underlying thought process, making sure you understand what the company does. Don't assume that because we're all brilliant, have worked on hard problems, and have had a lot of achievement, that's going to be immediately obvious to the person interviewing you, and that you'll be a good fit at the company. So there are lots of brilliant people from around the world, and we need to demonstrate that you're the best person for that company. So interviewing is something that's really underappreciated. Physics actually has kind of a reputation of being particularly poor interviewers, although being very good once you get through the door. What are some similarities between physics and academia and a data scientist at a startup? The biggest similarity is that the work is very similar on a day-to-day basis. You have a problem that's hard, you may not have an answer, and you want to study it and come up with a hypothesis, test that hypothesis, and propose a potential solution if it's a problem, or next steps like figuring out how to double down on it if it's something that's really good that's happening, like understanding and really exploring sort of the unknown is what's the most similar. What's a typical day? How's a typical day different than one in academia? So these, the days are fairly similar. The biggest difference is that when you have meetings are tight. You're getting together a lot of people. People are often very scheduled at startups, and so they have 30 minutes. You have to get a lot done in those 30 minutes, so you need to be very focused. You can't have digressions. And so being well-focused and and making sure you have a clear goal beforehand and afterwards is the biggest difference. Things that I found, like in academia, things tend to sprawl on for as much as time allowed, and people. In terms of day-to-day work, you aren't really punching a clock. There's a lot of flexibility. Show up to your meetings on time. But other than that, you can do what you want, work where you want. And every culture is slightly different, but it's very relaxed and casual. This is a very interesting one, and it's probably the biggest switch. Like, people wonder, how do I evaluate how I'm doing? Because in academia, we really have these metrical milestones, like how many papers I've written, how many citations they've got. And you aren't going to really get these outside of academia. Very few places have sort of those types of individual milestones. It's much more like how much you've contributed to the entire company and what skills you've developed, how you personally developed as a professional. So it's kind of a reorientation of what of how you think about evaluating yourself. It isn't about that individual impact necessarily. It's much more about how you've enabled the entire company to succeed at its overall mission. So kind of coming from academia, we're all kind of lone wolves out there, kind of working on our own individual careers, trying to become, do the best that we can. At a startup, you really want the entire company to succeed. And so in some sense, after that first year and I saw how much Quora had grown, I said, boy, this is more growth than I've seen in all of physics, and I feel like I have barely even done much of anything. I haven't worked the hardest I've ever worked, but I've contributed in these ways, and everyone else's work has amplified my own, and that's led to a big impact at the company. And I've also learned all these things to become better over time so that I can do more and make more impact. So it's a softer set of skills. Finally, how do I evaluate an offer from a startup? First, you should make sure that you like the startup. The culture matters a lot. You should make sure that you believe that the startup has a chance of succeeding. And then in terms of the overall compensation, you need to understand stock options, which are somewhat complicated, and I'm not going to describe them here, but they are a major component of your compensation, and understand them before you accept an offer is the thing. And you can ask on Quora. Okay, so I personally find working at startups exciting. We measure growth week over week, and that's really amazing. I find that the science that I do at Quora are really intellectually engaging, coming up with a lot of different, coming up with problems, lots of different problems from different directions. I find the culture overall very similar. It's very much about an ideas-driven culture. However, you're all working towards the same underlying mission. So I find it more supportive than, say, in academia. And it's exciting, fun, and meaningful. So thank you.
Questions?
Yeah.
Yeah, so one place where I've heard from people who left academia, mostly to consulting, so it might be a bit extreme, is the time scale on which you're supposed to solve a problem. Is this a concern when people leave academia as physicists and you give them a problem and 6 months later you're like, where is the result? And I've got a few more percent.
So first, there's lots of different different cultures. Most cultures, you're going to look to get the major impact in your understanding as quickly as possible. So you're going to want to get that rough estimate down, look for the mistakes, because it's very easy to get something wrong at first impression. And so as a data scientist, it's really important to have your work be trustworthy. So it's important to have high quality work, but you have to develop a sense of when you're getting to the point of diminishing returns. And you'll want to do that as quickly as possible, and not having to spend 6 months dragging a paper out. After 60 papers, I don't always mind that. There's still lots of documents that you produce internally, but they don't have to be quite as polished as having an introduction, an abstract, getting every reference right, so you don't upset your colleagues or people writing you letters. So so there is a difference, but I think it's less so than in like management consulting, where you're being outsourced to a different company. Here you're being directly employed by you're very much aligned with the mission of the company, as opposed to management consulting. Consulting in general, like you're ultimately employed by the consulting firm and aren't always 100% aligned with the company itself. That's an interesting question. I think that the answer is no. First, there aren't that many people in academia compared to industry. So it's not that big. There may be a change in I'm not sure if data science as a name will exist in 10, 15 years. It may become much more part of a job. You may have people become business analysts and then do data science. You may have people become software engineers and do data science. You may have product managers in data science. That just may be a core skill. And so that role with the name on it may change, but the underlying skills are going to become more valuable over time and more expected. Oh, what is it, about 85, 90%? Yeah. Most of them fail, and so they have different, so you usually describe the startup's age by which round of funding they're on. So you go out for funds usually periodically to get more funds, and so there's series, and they're lettered, A, B, C, D. Most fail going to the A round or going to the B round. So that's usually a couple of years, yes.
Are there any, also dealing with this nonlinear issue of, going global and taking over everything, that's addressing one problem and being the dominant for that one problem, but is there a similar nonlinear effect of going global and dominating over all?
Google does that, right?
Having Google dominate everything rather than you dominating this one.
That's, you're definitely wanting to, you definitely have to worry about major competitors coming in that have previous experience with domination. Yes, you do worry about that.
I'm not worrying not from your business point of view, from the future of the world point of view.
Yes, you do have to. I can say, if you look at Microsoft Office, people thought that Google Docs was going to be the Google Drive, whatever it's called, that's Google Suite, I don't know, was going to be its primary competitors. That was going to drive Microsoft Office out of existence. That hasn't happened. But there is a major threat now to Microsoft Office, not from another general purpose spreadsheet solution, but from people focusing on individual subcomponents that people frequently use spreadsheets for, and really doing it well, doing it much better than building your own spreadsheet for whatever, finance models, so on and so forth. And so that's actually, I think that's actually a much more likely how things are going to go. You're going to have domain expertise. The cost of building complex software that actually works and makes sense and is user-friendly has gone down. And so having domain-specific solutions is more feasible. Now, whether those get bought by is another story.
So where on the startup scale is Quora right now? And like, where does Quora see itself in like, I don't know, 10 years or so?
10 years, I think we hope to be profitable and probably public, although who knows, depending on regulation, whether you actually want to go public or not is an open question these days because of all the additional regulation. But being a healthy, profitable company is definitely where we want to be. We are now in the process of earning money. We are not profitable yet, but we are on our way up. So, in the yes, we have. It's actually been really amazing. There's been no pivots in any way, like changing the business model since day one. We were fortunate enough to see the original pitch to investors, and just, I don't know, a year ago, and just as kind of a historical oddity. And it's remarkable how little the underlying vision has changed. How we do various things obviously improves and grows, but our CEO and founder was really prescient, thought this out very carefully. Yeah, and yeah, I'm optimistic.
How do you get?
Advertising, so attention. So, and the reason why we think we offer advertisers something different than other platforms is, first, we have our own advertising platform, so we don't have those crappy things that follow you around, put interstitials up. We want to become big so that advertisers have a real reason to directly advertise on us. That means that we control the ads. So that means that we control the user experience, rather than like on, every website they have all those ad servers, which are horrible, right? So you don't control your product anymore. But then, by being big, we can also offer advertisers very targeted ads. So there are certain questions which indicate they're very likely to be in the perfect mood to make a financial decision, like whether it's buying a bar of soap or a car. And though that's very valuable to be at that point in time when they're evaluating different decisions, during the research phase. And there really isn't anything out there that's quite the same. Google is much more, makes their money on direct navigation. Like you want to go, take me to, Fidelity. Like how, whereas like between Fidelity and Robinhood or whatever, all these Wealthfront, different trading platforms and financial platforms, which one is best? That's a place that people want to be able to influence that decision and be able to present people with solutions. And so that's a very natural place to advertise. And by being big, we have a lot of those pages, and so people can actually target exactly what they want. And so that's why we think we have a meaningful product.
All right, last question. So on average, do people seem happier in academia or
I actually have an answer on this on Quora. I believe people's happiness levels are internal. So, sorry, yeah. So if you're happy, you're going to be happy in either. There are things that are particularly stressful at various stages in academia that can cause you to go out of equilibrium. But I was pretty happy in academia. I'm pretty happy in the startup world. I've known people who are always unhappy. So.
So after this, we have
Thank you.